Hello students, now we're going to talk about, we are going to move out and learn more about volcano, the volcanic landforms and what comes under the section of volcanoes. Volcanic materials has been deleted or exempted from your syllabus. So we're going to study about what explanation they've given about this, the liquid material, the solid material and the gaseous material. So there's some explanation which is being given in this regard. Now what about the liquid material over here? The liquid material is the molten rock material. When the molten rock material is below the earth's surface, it is called magma. Previous lecture, it's already been said and discussed that what is magma, what material is there beneath the earth's surface is called magma. When it appears on the surface, it is called lava, or when it oozes out, it is called lava. On the basis of percentage of silica, it is classified into two types. Now, there is silica present in it, and the percentage of silica defines or decides which type of lava is it. Is it acidic lava or basic lava? What is acidic lava? It contains higher percentage of silica. It has got high melting point. It is thick fluid and moves slowly. Basic lava, it contains less percentage of silica. It has low melting point. It's more fluid and can flow over longer distances. So two kinds of lava we are talking about, basic and acidic. Acidic has high melting point and contains high percentage of silica. Basic, it contains less percentage of silica and it has low melting point. Next, we go on to solid material. It is divided into three sections. That's liquid, solid and gaseous. In liquid material, acidic lava and basic lava. Solid material, it consists of dust particles and rock fragments, that is pieces. When the material is very fine, it is called volcanic dust. You all have seen dust particles. So when the material is very fine, it is called volcanic dust. The small sized solid particles are called ash. Now over here, the particles which come out, which are smaller in size and they are solid, it is called ash. The solid angular fragments are known as breccias. They are called breccias. The solid angular fragments are known as breccias. Sometimes the lava material thrown into the air solidifies into small fragments before falling on the earth's surface. These are called volcanic bombs. So if you see how ash turns into breccias and then what makes them or converts them to volcanic bombs. So all the solid material which comes out from the volcanoes, they are different shapes and sizes and they are different terminologies used for this material. The third part is the gaseous materials. At the time of volcanic eruption, a dark cloud of smoke can be seen over the crater. On the basis of shape, cloud is called cauliflower cloud. Various inflammable gases are found in these clouds. These gases produce flames. They actually produce flames. And there is a dark cloud in the previous lecture. I have shown you on how does a volcano actually look, and that's how you all can come to know there's a dark cloud which is formed above in the sky or seen over the crater, and the basis of the shape, it is called cauliflower cloud. The gases are flammable. So over here, liquid material, as I told you, lava and magma, there is a difference. The uh, beneath the surface is the magma, and which oozes out is the lava. Depending on the percentage of silica, there is acidic lava and there is basic lava. Acidic lava contains high percentage of silica and has high melting point. Basic has low melting point and contains less percentage, and it can flow for longer distances. Solid materials means the dust particles which come out, or their rock fragments which form out. from those. The small sized solid particles are called ash, and when they are angular fragments or angular pieces, they are called breccises. The lava then, when it is thrown and solidified before falling onto the earth's surface, it is called volcanic bombs. Now this gaseous material also is flammable, and it forms a dark cloud around the crater, can be seen over the crater, and on the basis of the shape it is called a cauliflower cloud. Now the next thing what we are going to learn about is volcanic landforms. Now what are volcanic landforms? First we'll understand this. Volcanic landforms. A number of landforms are formed due to cooling and solidification of magma. When magma cools down, there are different landforms, and when magma solidifies, there are different landforms. So different landforms due to the volcanic formations, we will come to know what are the different types of volcanic landforms. Volcanic landforms are divided into extrusive and intrusive landforms based on whether magma cools within the crust or above the crust. So it all depends upon how magma cools or solidifies. Rocks formed by the cooling of magma within the crust are called plutonic rocks. Rocks formed by cooling of lava above the surface are called igneous rocks. In your junior classes, you will have learnt about the different types of rocks. You will have learnt about sedimentary, igneous also. So metamorphic rocks also. So what are the plutonic rocks? Which are formed by the cooling of the magma, and rocks formed by the cooling of lava are igneous rocks. Now, igneous rocks play a very important role. They are used. In general, the term igneous rocks is used to refer to all rocks of volcanic origin. Extrusive volcanic landforms. Now over here, as I said, it is divided into extrusive and intrusive volcanic landforms. Extrusive landforms are formed from material thrown out to the surface during volcanic activity. The materials thrown out include lava flows, pyroclastic debris, debris means remains, volcanic bombs, as I said already, I repeated twice that how volcanic bombs are formed when that lava which is thrown out and solidifies into small fragments before coming down to the earth, they are called volcanic bombs. Ash, dust and gases such as nitrogen compounds, sulfur compounds and minor amounts of chlorine, hydrogen and argon. The first one what we are going to study about is lava domes. Now what are lava domes? Domes are developed when, this is on page 11, 10 and continued on page 11. Lava domes. Domes are developed when magma comes out and solidifies around its mouth. The shape of the dome depends upon the fluidity of lava. High dome with steep slopes, rising or falling sharply, steep, are developed by acidic lava. What is acidic lava? That has higher percentage of silica and has low melting point. Due to basic lava, broad-based low domes are developed. Now, because there is low percentage of lava, low percentage of silica, sorry, there are broad-based low domes which are developed. This is the figure how a lava dome is formed. A lava dome, volcanic dome, is a mound-shaped protrusion. It is a structure. This is some more extra information regarding lava domes. So I have given you all a picture showing that how does it exactly look and how does it protrude, how does a structure protrude. So a lava dome is a mound-shaped protrusion, a structure that extends outside the surface, resulting from the slow extrusion coming out of viscous lava from a volcano. In lava domes, viscous magma piles up around the vent. This is a part of the volcano crater, vent, all that we have studied. I had shown you all in the diagram. In lava domes, viscous magma piles up around the vent. The magma does not have enough gas or pressure to escape. Although sometimes later, after sufficient pressure builds up, it may erupt explosively. So this is how a lava dome is described. Now, how does it protrude from a volcanic vent? This is how it protrudes. Look at the picture over here, page number 11, 1.14. Next, we go on to lava plateaus. Due to spread of lava in huge quantity from fissure volcanoes, it covers large areas and plateaus are formed. The Deccan Trap in India has developed from volcanic eruption million years ago. If you look at this figure 1.15, that's lava plateau. So when the lava spreads in huge quantity, it covers large areas and plateaus are formed flat. So Deccan Trap in India is one such example which was formed or developed million years ago. Lava plateau. Now more information. What is it? What are they? They are formed by large outpourings of fluid lava from long narrow openings in the crust, in the fissures, cracks or fissures as I told in faulting. During each eruption, the lava flows out from these openings. What happens then? When lava flows out, it solidifies and it builds a new layer. When it solidifies, it becomes solid, thick. It builds a new layer each time, forming layer upon layer of solidified basalt lava. This is how we term it as lava plateau. The plateau looks flat, plateaus are flat, we know that, and featureless and often has little vegetation cover. So if you look in the picture, you will come to know that there is very less vegetation happening. Facts, the Deccan Plateau. Now if you look, it is in India. We have studied about different types: Chota Nagpur Plateau, Malwa Plateau, Deccan Plateau. We all know about this in our junior classes. It is 7 lakhs kilometers spread in area. It was formed by 29 lava flows from a hotspot which is now under Reunion Island in the Indian Ocean. Sometimes lava, this is some more information add on to lava plateau when you'll get a question which requires more detailing about different volcanic landforms. Students, you all can use this as add-on information for expanding your answers. Sometimes lava forms a plateau instead of a mountain. A lava plateau is a high level area. It forms when thin lava flows out of many long cracks. How does it form? When there's thin lava flowing out from those long cracks. Next, we're talking about caldera. At times, the eruption of a volcano brings about large quantity of material and relieves lot of pressure. After the eruption, what happens after the eruption? A large and a deep depression remains in that area. If you see, it's like a deep mound, deep well. This large depression is called caldera. So this volcanic landform where there is large depression, it is called caldera. This can be around 10 kilometers wide and hundreds of meters deep. So students, if you all see, different volcanic land formations are there. First one was lava dome, then lava plateau and caldera. They may later turn into lakes. Smaller calderas are known as craters. Smaller calderas are known as craters. So you all can see this in figure 1.16. Then when we come to the next one, that's a caldera. More information about caldera. In some volcanoes, the magma chamber below the surface may be emptied after volcanic eruptions. The volcanic material above the chamber collapses, totally collapses into the empty magma chamber, and the collapsed surface appears like a large cauldron, like hollow tub shaped. If you look at the figure, it looks like a tub which is wide 10 kilometers and very deep, which goes into hundreds, which is called the caldera. When water from rain or melted snow gets accumulated, now when water from in this deep depression, when water or snow gets accumulated, it becomes a caldera lake because it is formed due to a caldera, because of a caldera, that is a deep crater. In general, the caldera are also called crater lakes. Due to their unstable environment, some crater lakes exist only intermittently. Caldera lake, in contrast, can be quite large and long lasting. So it can be a little beneficial also. For example, if you see Lake Toba, that is there in Indonesia, formed after its super volcanic eruption around 75,000 years ago. Now, students, you all can see volcanoes which were dormant, that runs into millions years ago, hundreds years ago. It's like so many years uh, these eruptions have taken place or not taken place. It is the largest crater lake in the world. So this is an example, Lake Toba in Indonesia, which is the largest crater in the world. Mount Mazama Cascade Volcanic Arc, USA, collapsed into a caldera which was filled with water to form Crater Lake. Now, the literal name of the lake formed by the collapse of Mount Mazama is the Crater Lake. So, this is how it has been named, and it has happened naturally. These formations, land formations, have happened naturally in due course due to volcanoes, because we are studying volcanic landforms due to cooling and solidification of magma, which is due to volcanoes. So there are volcanic landforms. That's why caldera is one of them. Next we come to crater lake. Figure 1.17. When the funnel shaped, it looks like a funnel of an extinct volcano which does not occur, and it's been years, millions of years ago, it has not been active. So it's like it's no more there. Is filled with rainwater. It forms a crater lake. So when an extinct volcano is filled up with rainwater, it forms a crater lake. Volcanic plug. It is formed when the lava solidifies in the volcanic neck. This is another one. Volcanic plug. It is formed when the lava solidifies in the volcanic neck. Cinder cone. Solid material is ejected in large quantity. This material consists of solid material is ejected in large quantity. This material consists of ash, cinder, and breccias. Breccias, as we already know, its small sized solid particles are called ash. It is called ash. Cinders are half burnt pieces of solid material. The solid material is deposited around the mouth until a conical hill with steep slopes is formed. For example, Mount Nuovo in Italy. Cinder cone volcano. It is the simplest, most common type and has a characteristic cone shape. It forms when volcanic cinder blobs of congealed lava of basaltic composition comes out from single vent. This is more detailing about cinder cone volcano. It has explosive eruptions caused by gas rapidly expanding and escaping from the molten lava that comes out like a fountain. The lava cools quickly and falls as cinders that build up round the vent, forming a cone shape, leaving a crater at the summit. These volcanoes can be as high as 100 to 400 meters. The lava type is over here is less viscous, quite fluid basaltic lava enriched in iron. It is basically rich of iron, magnesium, and depleted in silica. Examples of these could be, if you call cinder cone, what are the examples? Lava Butte in Oregon, USA, Cerro Negro in Nicaragua, Central America, Paricutin in Mexico. Then the other one is composite cone. Composite cones are built up of alternate layers of lava and cinder. This cone is composed of two materials. and therefore it is called composite cone. It is symmetrical in shape. What is the example of this? Mount Helens, Mount St. Helens, USA. Composite volcanoes, what happens in composite volcanoes? If you see, lava flows alternate with explosive eruptions of ash, cinders and bombs. They are pyroelastic flows, tall cone shaped mountains. If you look at this, look at the diagram. There's a central vent, there's a crater which is there in between the lava layer you can see and the ash layer. Quite eruptions alternate with explosive eruptions forming layers of lava and ash. What is a composite layer? It is referred to as stratovolcanoes. It includes some of the world's grandest mountains. It is tall, conical, composed of an alternating layer of lava flow, which justifies the name composite volcano. It can have cluster of vents with lava breaking through walls or issuing from fissures on the sides of the mountains. The eruptions are extremely explosive and dangerous. The pressure builds in magma chambers as gases under immense heat and pressure are dissolved within the magma. When the magma reaches the vents, the pressure is released, given out, and the gases explode. Because of the gases explode, they explode violently. They can go up to 100 to 3,500 meters. In the previous one, cinder cone, it was 100 to 400. Over here, it is 100 to 3,500. What kind of lava is here? It is rhytholic lava that hardens before it can spread far. It has high content of silica. See, lava depends if it's acidic and basic depending on silica. It is low on iron and magnesium contents. Then we come down to distribution of earthquakes and volcanoes. There are three major belts of zones of earthquakes and volcanoes on Earth. This is Circum-Pacific Belt. This belt is also called as Ring of Fire. Previous class, Ring of Fire, I have explained it to you all, how earthquakes and volcanoes are active and what it's near the Pacific Ocean. It includes the volcanoes of eastern and western coastal areas of the Pacific Ocean. Most of high volcanic cones and volcanic mountains are seen in this belt. That's why it is called the Ring of Fire. Cotopaxi is the highest volcanic mountain of world found in this belt. Fujiyama in Japan, Mount St. Helens, Washington, USA, Pinatubo and Mayon, Philippines are other significant volcanoes. Now here we are talking about how earthquakes are distributed in certain sections and volcanoes. The mid-Atlantic belt. In this mid-Atlantic belt, what it covers, the volcanoes mainly along the mid-Atlantic ridge. The most active volcanic area in Iceland is found on the mid-Atlantic ridge. The mid-continental belt. This belt includes the volcanoes of Alpine mountain chains, the Mediterranean Sea, and the volcanoes of fault zone of Eastern Africa. The famous volcanoes are Stromboli and Etna. So these are the various distributions which are in three sections, that is Circum-Pacific Belt, that is the Ring of Fire. Pacific Ocean means Ring of Fire. Mid-Atlantic is the Iceland, which is covered. Mid-continental is the Mediterranean Sea, Alpine mountain chains, and Eastern Africa. So the famous volcanoes over here at the mid-continental belt are the Stromboli and the Etna. Here we can see there is a figure which I have given you all, a picture which shows the different types of volcanoes. Look how a cinder cone volcano is different from a composite volcano and what kind of lava flows out from each kind of these volcanoes. Shield volcano lava domes. How each one of that has different characteristics. Look at the volcano types. We studied about caldera, deep depression, this tub-like composite volcano. It flies around 100 meters to 3,500 meters. Shield volcano is not there in your syllabus. Fissure volcano we have already studied in the previous lecture. So these are the different types of volcanoes. This diagram or figure can definitely help you all identify different kinds of volcanoes and the different volcanic landforms which take place. Now, simple thing, what is a crater? Some information regarding a crater. It is an inverted cone-shaped vent through which the magma flows out. When the volcano is not active, means it's not happening regularly, the crater appears as a bowl-shaped depression. Depression means there's some depth in it. Bowl-shaped, it looks like that. The crater of Mount Fuji, Japan. When water from rain or melted snow gets accumulated in the crater, it becomes crater lake. As we discussed about a different kind of land formation, that was the crater lake. So this is some more information adding to that crater lake. Cinder cone also. A cinder cone is a steep circular or oval shaped hill of loose pyroclastic fragments that have been built around a volcanic vent. You all can see the central vent over here, the cinder cone crater, how is it formed and what are the rock fragments which can be seen. Ash, breccias, then we can see volcanic bombs, all the dust particles which come out in the liquid form, the dust which comes out, small solid particles which come out from those. Cinder cone volcanoes, ash, cinders and bombs, what comes out of it. So erupts explosively to form a cone-shaped hill. You can see the layers of cinders, then you can see the central vent in between, and then there's a crater, a huge depression formed. That's called a crater. This is add on to a different kind of volcanoes for your knowledge purpose. Shield volcanoes. Lava flows from quiet eruptions. Wide, gentle sloping mountain. This is some information about shield volcanoes. Then as I said, this is some more information, examples I had told you all to look out for, which are the different examples for active, dormant and extinct volcanoes. Active volcanoes, again, they have erupted in the last 10,000 years and I expect it to erupt again anytime. The examples are Mount Etna in Italy and Mount Lau in Hawaii. Dormant volcanoes. So this suffices that question which is being asked on page number 9. Find out examples of active, dormant and extinct volcanoes. You all can add on more to these. Dormant volcanoes, those that have not erupted in the last 10,000 years but are likely to erupt after remaining inactive for a longer period. Which are the examples of these? Mount Kilimanjaro in Africa and Mount Fuji in Japan. Last but not the least, extinct volcanoes. Those that were active in the past but have not erupted in the last 10,000 years and are not likely to erupt in the present or the future. So you all can see how to identify each of those volcanoes are defined and they have their own relevance and characteristics and examples allotted to those. Mount Kenya in Africa and Mount Aconcagua in South America. These three active volcanoes are a part of the topic of volcanoes. The different landform volcanoes, also what we learned were lava dome, lava plateau, caldera, crater lake, volcanic plug, cinder cone, crater I told you all, composite cone I told you all what is the information, what does it actually mean, what does a crater also mean, how there is a distribution of earthquakes and volcanic amongst the three belts which we've been talking about, that's circum-Pacific belt, mid-continental belt and mid-Atlantic belt. Then the different kinds of volcanoes and the examples associated with those. Look at the volcanic stage. See how things, how the diagram explains itself. Active volcano, dormant volcano, extinct volcano. So this is how it defines and sums it up for the different types of volcanoes and different landforms, the different materials of volcanoes. This sums it up for the first lesson. We are through with the first lesson. The next class will be on, we'll begin with the second lesson. Thank you, class.